All right, here is your notes for reaction types and predicting products, in case you need a refresher or you missed the class or whatever. So we're going to focus on these 5 types of reactions: single replacement, double displacement, combustion, synthesis, and decomposition. Honestly, the first 2 are the hardest. The bottom 3 are the easiest, so let's just start with the hardest first. So the generic form is A plus BC yields B plus AC. So what's really happening here is this A is kicking the B out. So now the B is alone and the A is with C. The important thing to mention here is that C is the right-hand side, right? It's the second ion in this compound, and here it's also the second ion in this compound because it's the negative, which you'll see in a second. So a specific example for this could be Na plus HCl, and this will be unbalanced. I apologize, there's just not much room in this box. NaCl. So what happened is the Na kicked the H out, the H is now alone. I know it's H2, that's just how it comes. I didn't invent the universe. And the Na is now with the Cl. When does this happen? This only happens if A is greater than B on the activity series. Now, you're probably thinking, what the heck is the activity series? Well, fortunately, on the very back of this sheet, it's right here for you. So, this only happens if A, which in this case is sodium, is greater than B, which in this case is hydrogen, on the activity series. So you just look, you find sodium right here, you find hydrogen right here. It is bigger, so this reaction will happen. That's why it's an example. All right, double displacement, it's just a little bit bigger. And like I said, I start with the 2 hard ones. AB plus CD yields AD plus CB. And it doesn't matter what order you put these in, right? You could do AD plus CB or CB plus AD. What matters is that whatever one was in the front has to be in the front. If one was on the back, it has to be on the back. So you can't have DA or BC, if that makes sense. Now, an example of this is the lab we just did, where we took some silver nitrate and we combined it with some sodium chloride, and we made silver chloride and sodium nitrate. So again, the A and the C just switch places. So the Ag goes with the Cl and the Na goes with the NO3. Again, remembering that the negative ion needs to stay on the right hand side and the positive ion needs to stay on the left hand side. This will only happen, however, if a solid will form. Well, how am I supposed to know if a solid will form? All right, back here, solubility rules. So let's talk about it. Just so I don't have to keep flipping back and forth, I'm going to tell you what we're dealing with. What you do is put it together like this and see what we're dealing with. We're dealing with AgCl and NaNO3. So I'm just going to write those over here so we don't have to keep flipping around. We're dealing with AgCl and NaNO3. So now what you do is you look and you find applicable rules. Usually the rules are going to apply to the negative ion, the anions, so the Cl and the NO3, but the positives play a role as well. So for instance, rule number 1 says alkali metals, which is the first column on the periodic table, so lithium, sodium, potassium, etc., are always soluble with no exception. So that means rule number 1 says that this is soluble. Soluble means aqueous, means it's not forming a solid. All right. But if we go down here to rule 4, it says chloride, which this is generally soluble, okay, unless it's with silver, mercury, or lead. So because this is chloride with silver, okay, this is rule number 4, telling you that a solid will form. So this is a solid, and this is aqueous. So since you do form a solid, this reaction happens. We'll see some examples down here where a reaction won't happen. But these are the two hard ones. These are the ones you got to really think about. You got to check the charts on. You got to do all that kind of stuff. The other three, much more straightforward. For instance, combustion. Combustion is some hydrocarbon. So I write CXHY, C something, H something, mixes with oxygen. And it always, always, always makes CO2 and H2O. This is a really, really nice example. You just don't have to really think a whole lot. So for instance, I could do CH4 plus O2. And so you're thinking, oh, is it a single replacement? It's not. If you have a C with an H and an O2, it's always just combustion, and your products are always CO2 and H2O. Every single time you have a hydrocarbon mixing with an oxygen. And when does this happen? Well, for us, always. So if you ever see a C something, H something with an O2, you just make the product CO2 and H2O. You have to balance it, so this isn't balanced. I think putting a 2 there and a 2 there would do it, but I'm kind of out of room. But either way, that's it. All right, synthesis. Synthesis is just putting two things together. A plus B equals AB, keeping in mind that the left one needs to be positive and the right one needs to be negative. And that's it. An example of this, we could do Mg plus O2 yields MgO. The only trick here is to keep in mind charges. If magnesium is a +2 and oxygen is a -2, then that's how they have to go together, one of each. Right? The only mistake people make here is they forget about the charges and they would put this like MgO2, which doesn't work because it doesn't take two -2s to cancel out a +2. When does this happen? Again, for us, we're going to keep this one easy, always. You ever see one element combining with one element, put them together, it's synthesis. Decomposition is just exactly the opposite. You have AB going to break down into A plus B. We like that. An example of this one is actually going to be pretty important in your life here in a couple weeks. Spoiler alert. And that's what that is. So again, it's one thing breaking down into two things. And again, for us, we're going to keep it easy and just say always. All right, so that's it. That's the first part of it. That's the lesson part of it. And then we can use all these examples to apply those lessons. So let's get started. So for some reason, I put probably the hardest one in the entire test, study guide, worksheet in class ever as the first option, the very first practice. I don't know why it happened, okay? So let's just do it. So again, what I like to do is I like to say, okay, if this is going to happen, what kind of reaction is it going to be? Well, I have two things combining with two things, so it's going to be a double displacement. So that means that these first ones are just going to switch places. The Fe is going to go with the PO4, and the Na is going to go with the Cl. So if the Fe goes with the PO4, and I'm not even going to worry about balancing it or charges or any of that business yet until I see if a reaction is actually going to happen. And the Na goes with the Cl. Again, remember, the thing that's in the front has to stay in the front. The thing that's in the front has to stay in the front. Back, 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 back. Now I need to see if either of these are going to be a solid, because this only happens if a solid will form. So FePO4 and NaCl. So again, I'll just write them up here just so we don't have to flip back and forth a whole bunch. So again, Na, just anytime you see a lithium, a sodium, a potassium, any of those alkali metals, you know that that's aqueous. You know that that's soluble. That's a really easy gimme, right? Same with nitrates and chlorates. They're always soluble. It's really, really easy. All right, here's phosphates. Phosphates are mentioned in Rule 5. It says phosphates are insoluble except for alkali metals, because again, Rule 1 says those are always soluble. So because of Rule 5, this is a solid. So we know a reaction is going to happen. Now the fun part. So because it's with 2 chlorine, you know iron must be a positive 2 charge. Because chlorine is -1, 2 negative 1s makes a -2, so that means that must be a positive 2. So if phosphate is a -3, you would know that either by looking at your polyatomic ion table or based on the fact that it's attached to 3 positive 1s here with sodium. So to make that, and this being a positive 2, in order to work that out, you have to have 3 of those and 2 of those, and that's our solid. NaCl works just like that, +1, -1. It works out. Everybody's happy. And then we just need to balance this real quick. A 3, a 2, and a 6 should do it, and we're good to go. All right. I kind of stepped on number 2's toes a little bit here, but we can probably figure it out. So again, 1 element type combining with 1 element type. So this is synthesis. We love this one. When does it happen? Always. So all I need to do, and I'm just going to kind of do it over here because I'm out of room, is put that Mg and that N together. But I need to make the charges work. So you know magnesium is a +2 because it's the second row over. And you know nitrogen is a -3 because it's in that column, right? It's technically the 4th row over from the right. So kind of similar situation here. You need 3 of those and 2 of those. Now all we do is balance it by putting a 3 in front of the magnesium, and we're done. All right, next. 1 element combining with 2 element types. So this is going to be a single replacement, right? This copper is trying to come in here and knock out this hydrogen. So in order for that to happen, the copper has to be greater than the hydrogen, right? For this copper to knock out the hydrogen, it has to be greater. So we look. Copper is right here. Hydrogen is right there. Copper is not stronger than hydrogen. So all you have to do for this one, and this is everyone's favorite, all you have to do for this is write no reaction. That's it. There's no reaction here because hydrogen is greater than copper, so copper is not going to be able to come in there and knock hydrogen out. All right, let's do number 4, which is another tricky one. Again, 2 things combining with 2 things, so it's double displacement. So we're going to just, again, quickly, just kind of not worry about charges, not worry about balancing, just kind of see what it is we're dealing with, and not just write the exact same thing over again, but actually flip them. So the Ni is now with the PO4, and the Li is now with the SO4. And then we come back over here to see if either of those will be a solid. Again, we're dealing with PO4 here, so that's almost always going to be a solid unless it's with one of those alkali metals. So that's why PO4 with lithium was aqueous, because lithium is an alkali metal, but PO4 with nickel is not. So this is solid, so we will in fact have a reaction here. SO4 is -2. Again, you would find that on your polyatomic sheet. So you know nickel here must be a +2. So it's exactly the same as number 1. If that's a number 2 and this is a -3, you need 3 of those, 2 of those, and that's your solid. And then lithium is a +1, sulfate is a -2, so you need 2 lithium, and that one is your aqueous. Now, of course, it's not balanced, so just a quick guess, I would say we need to put a 3 here, so we can put a 3 here, so we can put a 2 there, and that should do it. All right, number 5. Oh, we love 5, right? It's carbon and hydrogen with oxygen. That's it. So it's combustion. It's really, really easy, and every single time, it's just always going to make CO2 plus H2O. We love it. We love it. It's easy. Now balance it and you're done. All right. Next up, we have these double displacement. Well, these are the hardest ones, right? These are easily, by far, the hardest ones. I will definitely limit these on any test I give you. So same thing, switch the fronts. So the Na is with the SO4 and the Mg is with the NO3. And now we look back on the other side. But here's the fun thing. We have an alkali metal and we have a nitrate in each compound. There's our alkali metal and there's our nitrate. So alkali metals are always aqueous and nitrates are always aqueous. So what that means is we don't form a solid. A reaction only happens if a solid forms. So that means this whole thing doesn't matter. The answer is no reaction and we get to move on with our life. Now, again, 1 element plus 1 element. So we're going to just put them together. Because this is a transition metal, I can't expect you to know what its charge is going to be. So honestly, I'm not going to worry about the charges balancing. When you have a transition metal that's by itself, so you can't figure out its charge, right? In this case, we were able to figure out its charge. We were able to figure out its charge because it was connected to other things and we could think about it. In this case, there's no way to know. So I would honestly just do O2 right there. So it balances and you don't have to worry about balancing it. It makes your life a lot easier. All right. One thing combining with more than one thing. So this is going to be a single replacement, but it only works if PB is greater than Cu. So let's look. So PB, Cu, PB is greater than Cu, so it'll work out. But again, because this is by itself, I can't expect you to know its charge. So just make it easy on yourself and just say it's a +2 to work out with that -2 sulfate, and you're done. All right, last one on this type is Mg greater than potassium. Potassium's almost at the very top. Mg is not bigger than potassium, so this is no reaction. All right, the last 3, combustion of propane. All right, so you know combustion, I told you what it is. Of propane, you should know from chapters and chapters and chapters ago. If you need to draw it out, you can. You don't need to know its formula off the top of your head. You can say, okay, prop means 3 carbons. So off to the side here, we could even go, okay, 3 carbons. And then ane is all single bonds. So these are going to be surrounded by hydrogens. So do this. And then if you were to go and just count this all up, you would see it's C3H8 is what that ends up being. So combustion of propane, so we know we're going to have C3H8, and combustion means you mix it with oxygen and you make CO2 and H2O. And then of course we can balance it. All right, put a 3 carbon, 3 carbon, 8 hydrogen, 8 hydrogen. So this is 6 oxygen plus another 4 oxygen is 10 oxygen. So we need to put a 5 there. So we have 10 oxygen. All right. Addition of iron metal to silver nitrate. Silver always has a charge of +1. I would tell you that on a test or something, though. I wouldn't expect you to know that. So again, this is single replacement. So you just need to see, is iron greater than silver? There's iron. There's silver, it sure is, so this reaction does happen. And again, I can't expect you to know what iron's charge would be because it's a transition metal without me telling you, so just do that and we'll call it good. And then the last one is actually the example I gave you for the double displacement. It's the example that we did with the lab. It's a good one. We have NaCl aqueous combining with silver nitrate, also aqueous, meaning soluble, dissolved in water, yielding, and we would do this before, right? You would see that the Ag and the Cl will in fact form a solid. And then the Na and NO3 obviously won't, because Na never will due to Rule 1, and NO3 never will due to Rule 2, so altogether they will never form a solid. And that's how you do that. If you have any questions, let me know.